Okay, our last section in this chapter is on regular polygons. So if you look at our learning targets 1, I can recognize a regular polygon. So what does that mean to be regular? And then our other targets are I can find the measure of an exterior angle. Notice this is different. Yesterday we were finding some of exterior angles. Here we're finding an exterior angle of an equiangular polygon. I can apply the formula for finding the measure of an exterior angle to solve problems. All right, so we're going to be working with this whole idea of an exterior angle versus the sum of exterior angles. So let's review these terms here. If something is equilateral, right, for example, a rhombus is equilateral, and I hope you know that's because all the sides are congruent. An equiangular polygon, an example would be a rectangle because all of the angles are congruent. A regular polygon would be both, whoops, why am I putting an E there? Both equilateral and equiangular. So we've talked about an equilateral triangle, all those sides are congruent and all those angles are congruent. You could also think of a square is a regular polygon because all the sides are congruent and all the angles are congruent. Oops, I'm off the screen there. Sorry about that. All right, so equilateral sides, equiangular angles, regular polygon would be both. So an equilateral triangle is an example and a square is another example. All right, so let's talk about how do we find a particular exterior angle. And we're only going to be finding an exterior angle. If you look at the box down at the bottom of your page, we're only going to be finding an exterior angle if it is equiangular. In other words, all the angles have to be the same, or it could be a regular polygon. So if it's equiangular or regular, we can find those exterior angles. All right, so look at the example above, the sum of the exterior angles. Well, we learned that in the previous lesson. That's always 360, right? There are 5 exterior angles, so of course to find the measure of one exterior angle, we would take 360 and divide by 5, and that comes out to be 72 degrees. So it's actually pretty simple. We're just going to take what we learned yesterday, that the sum is 360, and we just divide by however many there are. So I'm going to put here E for exterior angle equals 360 divided by N, meaning the number of sides. Put that here, number of sides. Okay, and we can put the example. We don't have to do another one. That's just right up there. So simple enough. Take this 360 that we know is the sum and divide by however many there are. Well, let's look at how they can make you kind of apply this. So turn the page here and let's pull up that first example. Make sure I'm on the screen here. All right, how many degrees are there in each exterior angle, so we're not talking about sum, of an equiangular heptagon. A heptagon, remember, has 7 sides. So my formula for an exterior angle is 360 divided by the number of sides. So I'm looking for E, this exterior angle, and I know the number of sides is 7. So if I take 360 divided by 7, that doesn't come out so nice. That's about 51.4 degrees. Okay, simple as that. Here we're going to use it in the opposite direction. It says if each exterior angle is 18. So now I'm still on this formula, but much like we had the other day when we had some formulas and we used them both directions, they're giving you each exterior angle. So they're giving you this E right here, and they're looking for how many sides, so they're looking for N. So I plug the 18 in here. So if you've forgotten how to solve these, remember we can cross multiply. So I can say 18N equals 360, and then divide by 18. And I get N to equal 20. So it is a 20-sided polygon. All right. Number 3, if each angle of a polygon is 108. So I want you to really focus on this one. I'm going to highlight this. And I want you to look for a minute, how is this information different than the information that they gave you in number 2? How is this different from this? So hopefully when you look at those two sentences, you realize this one has the word exterior and this one does not. That's important because this is not an exterior angle they're giving you. It is an interior angle, but they're never really going to call it an interior angle. They're just going to call it an angle of a polygon. So this right here is telling you an interior angle. They're not giving you the sum of the interior angles, but they're giving you an interior angle, and they want the number of sides, so they want n. So I don't think I can start with that exterior angle formula because I don't know E, and I don't need to get E. So I'm going to take you back for a minute to something we had in the notes, right, from a previous day. So if you go back to this page, when we first started talking about exterior angles, the relationship between an exterior angle and an interior angle, right, remember these two add up to 180. And that is always going to be true. So although that really is not a formula, I am going to highlight it here because you're going to use it a lot. So one of the things you need to remember is that an interior angle plus an exterior angle add up to 180. So anytime you're given one, you can very easily get the other. So that's where I would start. They give me an interior angle. They give me I. So I know 108 plus the exterior angle should add up to 180, so that quickly tells me that my exterior angle is 72. Once I know the exterior angle, I can come over here and use my formula now. So I know 72 is my exterior angle, just like I did above. Now I'm going to cross multiply. And if I take 360 and I divide by 72, I'm going to get 5. And that's what it asks for. So this is really important here because if you don't know this, you're going to have trouble. We do not have a formula for I. This is the only thing we have with I in it is the fact that I and E together are supplementary. So anytime you're given an interior angle, you can immediately use it to get an exterior angle. Okay? All right, find the measure of each angle of a regular octagon. So when they say find the measure of each angle, do you notice what word is missing? Notice they don't say exterior angle. So again, in the absence of saying anything about what kind of an angle it is, that means it is an interior angle. So if they don't say the word exterior, they mean interior. Again, I don't have a formula for an interior angle other than this, but I don't know the exterior yet either. So I'm going to put the interior angle on hold, and I'm going to first find the exterior angle, which would be 360 divided by an octagon has 8 sides, so 360 divided by 8 is 45. So once I know the exterior is 45, do you now see how you can go back and get the interior? Because we have this relationship. So now I know that the interior plus the exterior add up to 180. So if the exterior is 45, I can quickly get the interior to be 135. And I've got it. Okay? All right, find the measure of each exterior angle of a regular quadrilateral. Okay, so remember regular means both sides and angles. All right, so sides and angles, we talked about that on the front page. A regular quadrilateral is a square because it has all the angles congruent and it has all the sides congruent. So if I extend, right, you can do this quickly by just looking at a picture. What is the measure of that angle right there? If this is 90, doesn't that angle have to be 90 degrees? Okay, and that's it for today's lesson.